Does anyone need me to do any bit of number one? So they're all in polar form and it's just raising to the power, right? Okay, and the modulus of all of them was 1, so you didn't even have to multiply numbers, right? Does anyone need any bit of number one? Right, number 6? Anyone need any bit of number 6? Excellent. Right, okay, so I have one more thing to do, and it's how to find the nth root of a complex number. Before I do that, I want to talk about the general polar form. Okay, so general polar form, I'm just going to talk about, this is me explaining what I'm going to do, so don't write in, I'm drawing a diagram next, don't draw it down, because it's just me going to be scribbling on the diagram. Okay, if we have a complex number and it's here, right, so say the complex number is here, so remember the modulus tells you how far from the origin it is, and the argument tells you its position on the plane. So between the modulus and the argument, it tells you exactly its position on the plane. Exactly? Would you agree? Okay, so just say the argument is 60 degrees. Okay, right? What if I said the argument was 420 degrees? Where would the number be on the plane? If I went 420 degrees that way, I'd end up in the same position, wouldn't I? Yeah, because I'd go all the way to 360 and then 60 again, that would be up to 420. So 60 degrees is in, right, the modulus isn't changing, so it's the same modulus, right? So would you agree that the complex number with the modulus of 60 degrees is actually the exact same as the complex number with with an argument? I keep saying modulus argument. So argument of 60 degrees is the same as a complex number with an argument of 420 degrees. Agreed? What would be another complex number that would be in the exact same position but it has a different argument? What would the argument be? 780 degrees. What did I do? How did you figure out 780 degrees? What did you do? You add on 360 every time, yeah? So if you add on 360 every time, okay, you'll end up with a complex number in the exact same position. Agreed? Okay, so when you have the argument, right, you just have one complex number in that position, but there's actually an infinite number, isn't there? Because you can keep going around and around and around, and you'll end up with, there's lots of different complex numbers in that position. Would you agree? Right, okay, so when the argument is less than 360, that's only one complex number that's in that exact position. But there's actually an infinite number of complex numbers in that same position. Right? Okay, agreed? That's where the general polar form comes from. Now, if you didn't get any of that, don't worry about it, because you just learn what this is. Right? Okay, we need general polar form, girls. Right? So the complex number, to write a complex number in general polar form, it's the r, which is the modulus, times cos of theta plus 2n pi, I'll explain what that is in a minute, plus I sine theta plus 2n pi. Right, okay, I'll explain what 2n pi means in a minute. Okay, so 2 pi, what would 2 pi be? How much is 2 pi? 360. Remember I said pi was 180 degrees? So 2 pi is 360. So you're adding on 360, but n can be any number. So you're adding on any number of 360s. So you can add, when n is 1, you're adding on 1 360. When n is 2, you're adding on 2 360s, okay? This is exactly what I just wrote there a minute ago. Instead of saying 360, I'm saying 2 pi. So it's 360n. You're marrying, or that's Loyola 1. They're very giddy today. Is it the noise upstairs? Yeah, they're very giddy today. it's all on camera now that they're very giddy today. It's April Fool's Day, it's driven them nuts, right? Okay, I had them earlier, right? Yeah, they very, very, very innocent, very lovely, but very giddy, right? Okay, so basically you're adding on any number of 360 degrees, right? Okay, and you get the same, you get a different complex number, but it's in the same position. So it's a different complex number, but it's in the same position, right? Okay, and we need to use this general polar form to solve the next bit. So how to find the nth root a complex number. Right, okay, again I'm going to doodle for a minute, so don't write any of this, okay? So in the section when we did De Moivre's theorem, I would have said here's a complex number. So I would have said here's a complex number 1 plus 2i, right? Okay, and then I would say, will you get me z to the power of 4? So you would tell me that you would say, so I said, will you get me z to the power of 4? So you do 1 plus 2i all to the power of 4. You'd multiply it out and you tell me what z to the power of 4 is. Agreed? Right. Okay. In this section, I'm going to give you the answer. So I'm going to tell you what z to the power of 4 is. And I'm going to ask you, well, what did I multiply by itself 4 times? Do you see the difference? So in the previous section, I told you the complex number and I asked you to raise it to a power of 4 and give me the answer. Now I'm going to give you the answer. I'm going to say, well, what did I raise to the power of whatever it is? Okay, so that's the nth root. You know, if I might say that if I said 2 to the power of 3 was 8. So I give you 2 and I say, what's 2 to the power of 3? And then I say, well, no, the answer is 8. What did I raise? What did I raise to the power of 3? Okay? Would you know, that's what I'm doing with complex numbers. So you're actually getting the third root of 8. Agreed? The third root of 8. Can anyone remember another way to write the third root of 8? 8 to the power of a third, isn't it? You know, if I asked you to get the square root of 4, you would say that would be 4 to the power of what? A half. Right? If I asked you for the 7th root of a number, what would that be? X to the power 1/7. Okay, so we will be using that we learnt right before. Is that right? Okay. So instead of saying here's a complex number, get it to the power of 4, I'm going to say you had a complex number, you got it to the power of 4, this is your answer, what was the complex number? Right? Okay. So I'm going to go straight to an example. Okay, and where am I? I'm going to get an example that's not done in the book. So if I go right, if I said, oh no, z cubed is equal to 8, right? So now it's a complex number, it's not 2, right? Okay, right? So z cubed, so I want to know what z is, right? So I'm telling you the answer was 8. So when I got z, raised it to the power of 3, the answer was 8. What was z? Okay, this is how, so I'm basically looking for z is equal to 8 to the power of a third. Would you agree? Cubed root of 8, 8 to the power of a third. Now there's more than one answer, right? Okay, yeah, 2 is an answer, but there's more than one answer. So it's 8 plus 0i all to the power of a third. Okay, so the first thing I have to do is I need to write it in general polar form. Okay, so I need to write it in general polar form. How you write it in general polar form is you write it in polar form and then you stick in a plus 2n pi onto it. Okay, so I need to write it in polar form, right? So polar form, then general polar form. Okay, so for polar form, remember I need the argument and I need the modulus, isn't that right? I don't need to calculate anything. It's 8 plus 0I, it'd be here. What would the modulus be? How far is that from the origin? 8. And what's the argument? What angle does it make with the positive sense of the x-axis? 0. So easy peasy one to start with. Is that right? Okay, so in polar form, that would be written as 8 times the cos of 0 plus, sorry, that should be a 0, not theta, cos of 0 plus I sine of 0. That's it in polar form. In general polar form, you just need to write cos of 0 plus 2n pi, and if you prefer plus 360, knock yourself out. Plus 3 or n 360, as in any numbers of 360, plus I sine 0 plus 2n pi, which means I can add on any number of 360s and I'm in the exact same position, right? So that's Z written as a or that is what was it, 8 written as in polar form. Agreed? Now I need to raise that all to the power of 1/3. Agreed? So I need to raise that all to the power of 1/3. So De Moivre's theorem says if you want to raise that to all to the power of 1/3, you raise the, what you call that, the modulus to the power of 1/3, right? And then you divide the angle, or you multiply the angle by 1/3. So 1/3 times that plus 2n pi plus I sine 1/3 times 0 plus 2n pi. That was De Moivre's theorem, what we learnt yesterday. Okay, so to raise it to a power, you raise the modulus to the power, and then you multiply the angle by whatever that number is. Are we happy with that? Nothing new so far except the 2n pi bit, right? So then a to the power of a third. What is a to the power of a third? 2, right? Okay, and here, right, I'm just going to, when you multiply by a third, you're really dividing by 3. I just want to write it like divided by 3 because it's just easier to work out then. I was going to give out, but they're on lunch, aren't they? Right, okay, so now it's written in general polar form, right? I still haven't solved, right? Okay, so what I should have said at the start, if you just bear with me a minute, if I go back to that, how many answers will I have? When it's to the power of a third, you'll have 3 answers. Because, right, okay, is that right? So you're going to have 3 answers. So, in order to get 3 answers, you start, and how do you know to do this? Because you learn it, right? So the first thing is you let n equal 0, right? N equals 0. So if I put, everywhere I see an n in there, I'm going to put in a 0. That would be 2 times the cos of, that would just be 0 over 3, isn't it? 0, cos of 0 plus I sine of 0. That's one answer. What do you think you do next? You let n equal what? N equal, 1, yeah, okay, so it's like you're doing a lap. So n equals 0, you're in the original position, right? N equals 1, you're doing a lap. Where do I end up, right? So you let n equal 1, so that means everywhere I see an n in there, right, I put in a 1, so that would be 0 plus 3, why do I keep writing theta? It's 0 plus, will I turn that to 360? It's 2 multiplied by 1 multiplied by pi, which is 360 over 3. Okay? Right, plus I sine 0. I'll sort all this out now and all these out in a minute, as in I'm going to simplify them all in a minute. Okay, but I'm going to write down the three answers. How do you think I'll get a third answer? Let n equal 2. Right, okay. So that would be 2 times cos of 0. So this time we're going to do 2 laps. Right, so it's the original angle plus 720 divided by 3. And then the sine, the angle over here is the same, is 0 times 0 plus 720 divided by 3. And that would give me 3 answers. How do I know it's 3 answers? Because it's the power of a third. If it was to the power of a quarter, there'd be 4 answers. So I'd have to go let n equal 3 and to get a 4th answer. If it was to the power of a 7, right, I'd have to do it 7 times. Right, what if you forgot to stop and you went in n equals 3? You would end up with the exact same answer. You'd still only end up with 3 answers. You'd end up with the first answer, and then if you went again, you'd end up with the second answer, etc. So don't worry about going too far. Just make sure you go far enough. Right, okay? They're your 3 answers. Okay, so the top one, you get cos of 0. That was so organised there for about 3 minutes. Here we are. So we're getting up here, the first answer, 2 times you get cos of 0. Cos of 0 is 1. And sine of 0 is 0. Right, that's your top answer. Right, then here we're getting 2 times, this would be 360 over 3, so you're getting cos of 120, yeah? All agreed that's 120? Cos of 120? So cos of 120 is, do it on the calculator please, I think it's minus a half. Yeah, and then do sine of 120. Sine of 120 is root 3 over 2? Root 3 over 2? Yeah. Okay, there's your second answer. And then here, right, it'll be 2 times cos of 720 divided by 3 is cos of 240. Do it on the calculator there for me. Cos of 240. It's minus a half again. And then get sine of 240. It's minus root 3 over 2. So that's plus I times minus root 3 over 2. And then multiply into your brackets. This would be 2. Multiply in here, it's minus 1 plus root 3i. And multiply in here, it would be minus 1 minus root 3i. And there's your 3 answers. Is that okay? I'll do another one now. I know it's a bit confusing to start with. Okay? So you have to find 3 answers. So you find 1 answer from polar form, and then you find 2 more answers from general polar form. You do laps. Okay? Right? And if it's to the power of a quarter, you're looking for 4 answers. And if it's to the power of 5, you're looking for 5 answers. It's power 1/5. If it's to the power of a half, you're looking for 2 answers. Always start with n equals 0. Common mistake, people forget n equals 0 and do n equals 1. Remember, n equals 0 means the original position, no lap. So when n equals 1, you do 1 lap. When n equals 2, you do 2 laps, etc. Right? So remember to start with n equals 0. Common mistake, people go straight to n equals 1. Right? I'll do a second example. Right? So example 2. I don't want to do that one because it's pretty much the same. So z squared. So I'm not telling you what the original complex number is, but I'm telling you when I squared it, this is what I ended up with. So I don't know what the original complex number is. I haven't told you what z is, right? But I've told you after I square z, this is what I end up with. So I have to solve, I'm basically solving the equation 2 plus 2 root 3i all to the power of what? All to the power of a half. Agreed? Right, how many answers? 2. There'll be 2 answers. Okay? Right. So I have to express it in polar form, then in general polar form. Okay? So to express it in polar form, I need a sketch. So to cross 2, it's up to 2 root 3. So it's cross to 2, and it's up 2 root 3. So there it is. Okay? I need the modulus and I need the argument. Okay, so I need the modulus and I need the argument. So the modulus is r is equal to the square root of 2 squared plus 2 root 3 2b squared, which I think works out to be 4. 2 squared is 4, add 4 by 3 is 12. Yeah, square root of 16, it works out to be 4. Is that right? Calculator job. Okay, right. And then I have to work out the argument, so I need my right angle triangle. So it's across 2 and it's up 2 root 3, and the argument is actually the angle in the right angle triangle. Okay, so I don't need to add or subtract it from 180. So the tan of theta is equal to opposite. By something? Do you want to close the door? Yeah, then we die of COVID and you all sue me. But you'll be dead, you won't be able to sue me, it's fine. Do you want to close the door? Are you comfortable closing the door? Yeah, close the door. 2 root 3, anyway, look, I'm nearly finished. 2 root 2 over 2, right, okay, so that's root 3. So tan of theta is root 3, so that means theta inverse tan of 2 root 3 over 2, and you get 60. So that is your actual argument, isn't it? You know, sometimes I had to add it to 180 or subtract it from 180 or something, but here it's in the first quadrant, so it's fine. Okay, so in polar form, that is 4 times cos of 60 plus I sine of 60. Okay, so to solve equations, I need to put it in general polar form. So all I need to do is put in on a 2n pi. So it's cos of, you might be more comfortable with 360n. Would that be better? Instead of 2n pi, will I call it 360n? It might be make you more comfortable because of this pi thing. I think it puts people off. So it's cos of 60 plus 360n. So that means you're doing laps of 360. Right? Okay? Plus I sine 60 plus 360n. So you have to do laps, right? Okay, but the thing is, you have to raise that to the power of a half. That was the whole point of the polar form. I have to raise it to the power of a half. So De Moivre's theorem, can I move this up? Have I cut people off? De Moivre's theorem says you raise the modulus to the power, and then you multiply the angles by the power. So it's a half times 60 plus 360n plus I sine 60 plus 360n. Sorry, did I forget to put the half there in front? Okay, is that alright? Are we good with that? So then you let that, you can change that to 2, and I might change this to 60 plus 360n over 2. Multiply by half is the same as dividing by 2, plus I sine 60 plus 360n over 2. Are we okay with that? And then you have to get 2 answers. So how do you get the first answer? N equals 0. Right, so everywhere, sorry, there should be an n there. Everywhere I see an n, put in a 0. So that would be 2 times, that would be the cos of 60 plus 0 over 2, which would be 30. Plus I sine 60 plus 0 over 2 would be 30. Okay, and then to get the next answer, you let n equal 1. So everywhere I see an n, put in a 1. So that would be 60 plus 360 times 1, which would be 420, divided by 2 would be 210. I sine 210, and then you change them back to rectangular form or Cartesian form. So the first answer would be 2 times cos of 30. Cos of 30 is, where am I, root 3 over 2. And sine of 30 is a half. So I times a half. That's answer number 1. And answer number 2 is 2 times cos of 210 is minus root 3 over 2. And sine of 210 is minus a half. Okay. Right, and then multiply in. So you get root 3 plus I, and here you'll get minus root 3 minus I. Is that okay? Okay, I know we're not there yet, but let's have a go, right? See how we get on, and we'll iron it out on Monday. So if we do page page 38, 8, 9. So when do you use this method? You use this method when you're not given the complex number, you're given the answer. So it's straightforward. De Moivre's theorem is saying, here's the complex number, raise it to a power. But you use this method when it said, here's the answer when you raised it to a power, what did you raise to the power? Okay? Right. Are we on lunch?